It's not that deep. All right, so I know that the formula for the midpoint tells me that I'm going to get x1 plus x2 all divided by 2. And I'm going to get y1 plus y2 all divided by 2. All right, so all I'm going to do is I'm going to substitute in there. I'm just going to say this is my x1, and this, if this is x1, then this is y1. And over here, I'm going to make this x2 and y2. All we're going to do is just sub in. So I'm going to get the midpoint of my x1 value is minus p minus 9k plus k. And then over here, I've got, let me move that, 9k plus negative 7p plus 7k. All of that over 2. And then for my y values, I'm going to get 6z minus 7m plus 2z. And now I'm writing x. 2z minus 7m. All of this over 2. Okay. So for the midpoint, I'm going to get, and then I just need to add like terms, guys. I'm going to take negative p minus 7p, plus and minus will give me negative 7p. That will give me minus 8p. And then I'm going to get negative 9k plus 7k will give us negative 2k minus 2k, all of this over 2. Then on this side, again, we'll just add like terms. 6z plus 2z will give us 8z. And then my m's, negative 7m minus 7m will give me negative 14m over 2. All right. And luckily for me, all of these variables or all of these expressions are divisible by 2. So negative 8p divided by 2 will give us negative 4p. And negative 2k divided by 2 will give us negative k. Right. On this side, I'm going to get 8z divided by 2 will give me 4z. And negative 14m divided by 2 will give me negative 7m. All right. And that's the answer that ma'am is looking for. That's the one. Okay. I hope we're all doing okay. This was a bit of a tricky question, but the only tricky thing really was that there was a lot of M's and Z's and things. Other than that, the maths still holds. Nothing different here. All right. I hope everybody's doing well, and that we've had a great weekend and that we're caught up on today. I know exams are coming up. For those of you who joined, I'm sorry, Narisha. I'll ask it differently. Okay. For those of you who joined me for the boot camp on Saturday, or all 3 boot camps, thank you so much for doing so. I hope you learned a lot, and I hope you got a lot out of the lessons. The recordings will be up on YouTube for those of you who didn't join us. Unfortunately, the material that we used during the boot camp will not be available because that's only available at the price point that we've given. All right, but thank you for joining us. Let's get started on to, oh, shame, Pumzile and Nisha are writing science, English and science and physics, respectively. And I feel for both of you, though Pumzile, I'm also an English major. I'm curious to know how you did. Okay, Narisha, I can't help you with your physics, even though I also did do physics. I know it humbles a lot of people. I'm glad. All right, let's talk about the gradient formula today. Thumbs up. I just need to check with everyone before we continue. Thumbs up if you've already started analytical geometry at school, or thumbs down if you have not. Just so I know how thoroughly to go through this. Oh, Khulani is done, and probably on to functions, I hope, Khulani, because that's what we're going to be doing next. We're going to start functions on Monday. Ah, lovely. Okay, cool beans. So I should get around to functions before. Oh, I love it. Yo, Omi's done with functions. Sure, that's far. Jeez, guys. Whew. Maths paper 1 on Monday, guys. All right, I'm very sorry for those of you who didn't quite get a chance for me to go through functions before you write. Okay, my best advice would be to go to our YouTube channel and check out the lessons I did on functions last year. Okay. And I'm still going to get there, Boucher. I've just added functions. I've added trig functions to actual functions. So we're going to do it all at the same time. Oh, I see. Okay, that's okay, Vukosi. It just means they've swapped them around at your school. So we'll get there. All right, let's talk about the gradient formula quickly. Where else have we seen this gradient formula? Who's seen this before? I'll give you a hint. In grade 9, we spoke about the gradient formula before. Where did we see it? Where did we see it, Andisa? You're like, yes. Where? Where have we seen the gradient formula before? What were we learning about at that time? The Cartesian plane, correct. We were learning about graphs, right? And Andisa hit it nail on the head. It was about straight line graphs specifically, right? When we're talking about a straight line graph, we're always going to get a gradient. It's a slope, right? So we're going to get m is equal to something. So if we're looking at the straight line graph, we know we've got y is equal to mx plus c, and that m part, that gradient part, the way we would calculate for the gradient is to use this formula over here. Y2 minus y1 is over x2 minus x1. All right, let's look at an example because this is exactly what it is that we're going to be using today. Obviously, it's not going to be that easy. There are some times when ma'am's going to challenge you a little bit more, and then we'll chat about that when we get there. But if I look for the gradient of these two lines over here, as always, I'm going to number them. So, or label them. I'm going to call this x2, y2, and I'm going to call this x1, y1. And then I can calculate for the gradient. So I know my gradient is going to be y2, which is 11, minus y1, which is 5, over x2, which is 4, minus x1, which is 1, right? And then we just need to look at the top, look at the bottom. 11 minus 5 will give us 6 on the top, divided by 4 minus 1 at the bottom will give us 3. Therefore, the gradient of A is 2. That's the gradient. All right. If we do the same with question B over here, again, x1, y1, x2, y2, right? The gradient is going to equal to y2 minus y1, so 8 minus 0 over x2 minus x1, which is 6 minus 4. And that will give me 8 over 6 minus 4 is 2. And that will give me a gradient of 4. All right, and it's that simple to calculate for the gradient. I don't think it's that difficult. I'm going to give you guys an exercise to try. We're not going to do everything. We're only going to do no, it doesn't. We're only going to do that. Okay, A, B, and C. Okay, Pumizile, I want you to be very careful for me. When you say, does it matter which set of coordinates you use? Not really, as long as they are all on the same line. So if there was another line over here, let's say, for instance, there was another coordinate that they gave us there. If they managed to give us that coordinate, as long as it's on the line, it doesn't really matter. These 3 points are called colinear. They're called colinear, which means all 3 of these points, and even if I add a 4th one and I add a 5th one, all of them will have the same gradient because they all lie on the same line. Hello, Abu. Okay, so it doesn't matter which one I use. However, not in this case, Narisha, not particularly, because that will be then a different type of graph. Okay, where we would have to calculate for a slope in a different way. Okay. Right. So Pumizile, just be careful. Remember, if we name this x1, you cannot now decide that this is y2. It's not how it works. You can't do that. If this is x1, this is the corresponding y value. So this must be y1 as well. All right. I had one of my kids say, do this, x1 and x2. You're not allowed to do that either. That's incorrect, right? Because when we write coordinates, we write an x value and a y value. So we can't decide that they're both x values and the others are both y values. No, we don't do that. So you've got to just label them correctly. Okay. Pop your favorite emoji in the chat when you're ready. It is a little bit of geography. But then again, we did say that analytical geometry helps us, work out GPSs, which sounds like geography to me. It's about the same. Yes, Google Maps uses geometry. Yes, analytical geometry. It does. One more minute, guys. We should all be finishing up though. Okay. By the looks of things, I don't need to add that extra minute. It looks like everybody's kind of already there, right? Okay, so I'm gonna do a quick cheat, and I'm just gonna go down the line: x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, and x2, y2. All right, and then I'm just gonna calculate the gradient. Let's start with A. M is equal to y2 minus y1, so 10 minus 4 over x2, 3 minus 1. 10 minus 4 will give us 6, 3 minus 1 will give us 2, so the gradient should be 3. All right, 1 mark if you managed. B over here, the gradient is equal to y2, which is 12 minus 0 over x2, which is 3 minus 0. This is equal to 12 divided by 3. That will give us a gradient of 4. Okay, for C, y2, the gradient is going to equal y2, which is 14 minus negative 2 over 9 minus 5. All right, 14 minus negative 2, that will give us positive. So 14 plus 2 is 16 over 9 minus 5 is 4. Therefore, the answer we should get here is 4 as well. All right, how did we do? How much did we get out of 3? Is equal to y2 minus y1 over x2 minus x1. All right, nice. I knew we would all get it. There we go, Mbulelo, sorry. Sorry if I didn't write it on the screen. It's because we just looked at it. But there it is. Make sure you write it down because I am going to scroll again and I don't want you to forget it. Okay, we're going to need it. All right, shall we step it up a notch as always? Yes? Let's step it up a bit. Let's do it. Narisha always running away from her responsibilities. Okay, let's talk about what happens when we're given the gradient. All right, so we're going to skip question 2 for now. We'll come back if we have time. We're going to start at question 3. Let's start over here. So they're telling us in this question that we've got the line passing through 5 and negative 2 and 8 and C has a gradient of 3. So in this particular question, they've given us the gradient, right? And they want us to find the value of C, which is a y coordinate. Now, I'm not going to do anything different, grade 10s. I'm still going to label x1, y1, and I'm going to label this x2, y2. The only difference is now they've given me what the answer for the gradient would be. So where normally I would say m is equal to something, in this case, instead of just writing m, I'm going to replace m with 3. Right, I'm going to replace m with 3. So I'm going to go 3 is equal to y2, which is c, minus y1, which is negative 2, over x2, which is 8, minus x1, which is 5. And then basically we're just solving for c. Right, so I'm going to get 3 is equal to c, a negative and a negative will give us plus 2 over 8 minus 5, which is 3. Right, now I want to get that 3 out of the denominator, so I'm going to multiply both sides by 3 times by 3. These two will cancel each other out. Now I'll have 3 times 3 is equal to 9, which is equal to c plus 2. I'm going to take the plus 2 over to the other side, and it's going to become -2. Therefore, C is equal to 7. All right. And it's that simple, guys. Okay, I'm going to give you guys a few minutes. Okay, I'm going to give you about 5 minutes to do the next 3 questions. Question 4, question 5, and question 6. Not really, Andiswa, no. And I'll tell you why. Andiswa is asking, do you get marked? Do you lose marks if you don't write down the formula? No, you don't. Because for analytical geometry, the formulas are given to you. Okay, so it's something that they must give you. They must give you every single formula. So your gradient formula, your midpoint formula, your distance formula, all of those they must give to you. So no, they're not going to mark you down for not writing down the formula. It's something that they give you, right? It's the application that we're after mostly in analytical geometry. Okay. All right, pop your favorite emojis in the chat when you are ready. One more minute, guys. I know question 6 is quite a tough one, but we'll chat. Don't stress, guys. All right, peeps, let's have a look at some of these answers. All right, let's have a look quickly at question 4. All right, so we know the formula for the gradient. Oh, now I'm writing in highlighter, my word. All right, let's look at question 4 quickly. So I know the gradient, the formula for the gradient is m is equal to something. But in this case, they've already given me m. So I'm going to replace m with 4. I'm going to replace m with 4. So I need to go 4 is equal to, I'm going to name this x1, y1, and x2, y2. Right, so y2 minus y1 will give us h minus -9 over x2, which is -2 minus -8. That's going to give us h plus 9 over -2 plus 8 will give us +6, and all of this is equal to 4. So I need to get that 6 out of the denominator, so multiply by 6 on both sides. So I should then get 24. 6 times 4 is 24 is equal to h plus 9. Right, I take the 9 over to the other side and become -9. Therefore, h is equal to 15. 24 minus 9 will give us 15. Right, that's what we get for number 4. Let's look at number 5. Number 5, again, they've given us the gradient. We know that we're going to replace m with 2. So I should get 2 is equal to, again, let's number x1, y1, x2, y2. No, question 5 is going to be a little bit trickier. So over here, we're going to get 2 is equal to y2, which is 10, minus -4 over, now what x2 is m minus 3. Right, so if I simplify this, I should get 2 is equal to 10 minus -4 will give us +4. So 10 plus 4 will give us 14 over m minus 3. Okay, 14 plus that. Now I want m minus 3 out of the denominator, but if I multiply this side by m minus 3, I'm going to have to multiply this side by m minus 3. But because there's a 2 here, I'm then going to have to multiply the whole of m minus 3 by 2. So those 2 will cancel. And I should then have 2, and in brackets, m minus 3 is equal to 14. Now, this means that I must distribute. Right, so I'm going to end up with 2m minus 6 is equal to 14. I'm going to take the -6 over to the other side, and it's going to become +6. Okay, I'll carry on just on this side here. It's going to become +6. So I'm going to have 2m is equal to 20, 14 plus 6. 2m is equal to 20. Therefore, m is equal to 10. Right, that's what we should get there. All right, for number 6, I want us to have a quick chat about negative fractions, because it's quite important that we understand exactly what it is we're looking at when we look at this. Okay, we've been given a gradient over here of -1/2. They've given us a gradient of -1/2. So let me use another example. If I said to you guys that I've got -3/4, just -3/4, right? Where does that negative belong? Does it go to the top of my fraction or to the bottom of my fraction? Where do I put that -3? Is it at the top or is it at the bottom? Let me write this a little bit better. Good, Theo, that's correct. Okay, Theo's correct. And Abu, technically there's no wrong answer here. If you had said it goes on the top, you would have been correct. If you said it goes on the bottom, you would have been correct. Both of those answers are correct. It can go anywhere, right? Let's think about exactly. Yes, let's think about exactly what this means. If I have to have two fractions, something over something is equal to a negative answer. If I had to get a negative answer out, if I decide that the top number is going to be positive, what must my bottom number be in order for this to be true? Yes, bottom must be negative. Correct, Abu. So the bottom would have to be negative, right? So if I then choose that I want the top to be negative, that means that my bottom should then be positive. in order for me to get out a negative. So they can't both be negative and they can't both be positive, because if I want a negative, I need to have opposing signs. All right, so let's look at number 6 quickly. If we look at question 6, it says that the line passing between these 2 points has a gradient of -1/2. So if I have a -1/2 as an answer, it doesn't matter whether I make the -1 or the 1 negative, or if I make the 2 negative. The answer that I get out will be exactly the same. So I know I must replace the m in my gradient with -1/2. I'm going to make the 1 negative. So I'm going to write -1/2 is equal to, then I'm going to go label again. So I'm going to make x1 and y1 there, and x2 and y2 here. And then we're just going to calculate for the gradient the way that we would, right? I'm going to get n for y2 minus y1, which is 5, over x2, which is 2, minus -2, which will then give us +2 at the bottom. All right, so I'm going to get -1/2 is equal to 9 minus 5 over 2 plus 2 will give us 4. Now, when I have two fractions like this, what I can do is I can cross multiply. So I'm going to get 4 times -1 will give me -4. And that is equal to, now 2 multiplied by n minus 5 means that I must put this in brackets, n minus 5. And then I must distribute. All right. So I'm going to get -4 is equal to 2n minus 10. I'm going to take the -10 over to the other side. It's going to become +10. So I'm going to get -4 plus 10 will give me +6 is equal to 2n. Divide both sides by 2, and therefore n should equal 3. Correct. Therefore, n is equal 3, or 3 is equal to n. Both of those will be correct. All right. And that's the answer we should get. How did we do? Out of 3. Did we get 3 out of 3 for question 4, 5, and 6? How did we do, guys? Is it the last one, Omi? It's probably question 6. Yes? It was a bit of a tough one, I know. Okay. Well done, Pumzile. Doing great. Doing lovely. All right. So just bear that in mind, guys, that when our whole fraction is negative, then we can get a negative and a positive, or we can get a positive and a negative. Now, I want us to be careful. Can I just, let me extend this a little bit. Okay. I'm going to extend this a little bit while I scroll so Vukosi can take some notes, right? Let's go back to this exact analogy that ma'am, or this exact example that ma'am's got over here. If I've got two numbers, one over the other, and I want my answer to be positive, let's talk about my options over here, guys. What options do I get? If I want my answer to be positive, correct, they must either both be positive, because a positive divided by a positive will give us a positive, or they must both be negative. They must both be negative. All right. They must both be negative and negative. Now, this is going to come up again. All right. Let's think about when we did trigonometry. Do you remember when we were doing trigonometry on a Cartesian plane? We would come across a question that would look like this. And they would tell us that we've got, let me do it this way, 3 tan of theta is equal to 5. And they tell us that theta needs to be in between 180 degrees and 360 degrees. We can include both of those, in fact. 360 degrees. Theta needs to be in between 180 and 360. Now, if I draw my Cartesian plane as I would for trigonometry, 180 degrees, 270 degrees, and 360 degrees is over here as well, right? I know that I need to use tan of theta, but now I've got a 3 here. So what I would do is I would divide this side by 3, and I would divide this side by 3. Now, if we think about the information that they've given us, grade 10s, they've told us that theta needs to be between 180 degrees and 360 degrees. That is between here and here. It's either in this quadrant or in that quadrant. But now, if we look at our answer for tan of theta, we've got tan of theta is equal to 5/3, right? I need tan to be positive. That's my x, and that's my negative x. That is y, and that is negative y. If I need tan to be positive, there are possibly two ways that tan can be positive. That's if I have a positive x value and I have a positive y value, or if I have a negative x value and a negative y value. So Abu, you are 100% on the money. If both of these values are positive, in order for them to stay positive, they can either be a positive and a positive, or they could be a negative and a negative, a negative and a negative, which means my value, or the line that I need to draw for tan, would need to be in that quadrant. Okay, thumbs up. Does everybody understand what ma'am is saying? It's going to come up again, grade 10s, and we need to be able to distinguish between these two things. Are we all okay with this? Okay, the fraction idea behind it is quite important. Vukosi, tell me where I've lost you. Okay, tell me where I've lost you so that I can fix it. Okay, remember, if they ask for a fraction and they give us that the fraction is positive, the answer for both of these fractions is positive. There are two possible answers. Either both the top and the bottom are positive, or both the top and the bottom are negative. Both of them are negative. Right. Now, if we think about it, I know that tan of theta is equal to opposite over adjacent. Our opposite is our y value, and our adjacent is our x value. So the only way we're going to be able to get tan to be positive is if my y value is positive and my x value is positive, or if my y value is negative and my x value is negative. If both of them are negative or both of them are positive, that's how I end up with a positive answer for tan. Okay, and that's what ma'am is getting at. All right, we okay with that? So it could have either been in this quadrant where they're both positive, or it could be in this quadrant where they're both negative. But because ma'am has told you that theta needs to be between 180 and 360, this one between 0 and 90 is a no-go. The one between 0 and 90 will not work. We have to use the one between 180 and 360, which is over here, where they're both negative. All right? Okay, lovely. Okay, let's talk about parallel and perpendicular lines. Okay, because they're going to come up in analytical geometry. So let me ask you guys, who can remind me, what is the defining feature of two parallel lines? Well, how do we define two parallel lines? Okay, correct. According to analytical geometry, the gradient is the same, yes, but just any random two parallel lines. What do we know about two parallel lines? They don't touch, correct. They never meet, right? They will never ever cross each other. They won't cross each other. Now, the reason why we know this, that they will not cross each other, is because they are the same distance apart everywhere, right? That's it. Correct, Pumizila. That's true as well, right? So it's not about the distance between, or the distance that they are. It's about the distance between them. Okay, correct. Okay, so they can never be together. You make it sound like Romeo and Juliet all over again. Okay, yes. So this is Romeo, and that is Juliet. Okay. They're parallel lines. They're like Romeo and Juliet. All right. So, okay, the point that ma'am is trying to get at is that these two lines are equidistant. They are equidistant, which means that the two lines will always be the same distance apart from each other. All right. So I'm going to draw you guys a straight line like that. Right. If I draw a straight line and I tell you guys that this point here is 0, 2, and this point over here is -2 and 0. I would like you guys to determine the gradient of this line for me. What is the gradient of this line over here? Be careful, Abu. Be very careful. We're going to make this x2 and y2, and we're going to make this x1 and y1. Right? Calculate for me, peeps, and tell me what we get as a gradient. M is equal to, y2 is 2, minus 0, and at the bottom I'm going to get 0 minus -2. What's going to happen there? I'm going to get 2 over a negative, and a negative will give us positive 2. That's it. 2 over 2 is equal to 1. Right. So the gradient of this line is 1. The gradient is 1. Right. Now, if I decide, no worries. Remember, Abu, this is the place to make mistakes. If I decide that I'm going to draw a line that is exactly equidistant to this one and parallel to that one, right? I'm going to say that this point over here is 0 and 4. Now, do we notice how my x value hasn't changed? I haven't changed the x values. I've only changed the y values. You see that? The y values have changed. So if I've moved from here to there, according to my y values, if this is my x coordinate over here is -2 and 0, what would that point over there be? I know my x value is not going to change. It's still going to be -2. What is my y value going to be here? It is correct, Abu. It is 2, right? Because I've moved from my y value over here. I've moved from 2 to 4. Yes? So if I've moved from 2 to 4, that means I've moved 2 units up. And if I'm trying to create 2 lines that are parallel, that are equidistant, I need to move 2 units up over here as well, which means the value over here is going to be 2. Now, if I asked you guys then to calculate for the gradient of this second line, what is that gradient going to equal? The gradient of line 1 is 1. We've calculated for that. Let's calculate for the gradient of line 2. I'm going to get, again, I'm going to name x2, y2, x1, y1. Let's calculate. Gradient is going to be y2, which is 4 minus 2, over x2 is 0, minus -2. All right. The reason why the x values doesn't change is because I haven't moved the graph in any direction that way. I haven't moved it this way. I've just taken the line and I've moved it up. Okay, I've just moved it up. So that doesn't affect the x values. It only affects the y values. All right. Okay, I'm going to get 4 minus 2 will give me 2 over the top, and a negative will give us a positive 2. Therefore, the gradient will be 1. Right, so the gradient of the second line is also 1. So we can see that as long as 2 lines are equidistant, we know that when they are equidistant, they will also be parallel to each other. But if they're parallel to each other, what do we notice about the gradients? The gradient, if they are parallel lines, the gradients must be equal. Parallel lines tells me that the gradient of line 1 must equal the gradient of line 2. All right, so if I decided to draw another line that is again equidistance, if it is the same distance everywhere in this direction, if they're the same direction, or if they're the same length in each direction, I know that that means that the 2 lines are parallel, which means they will have the same gradient. So I don't even have to know much about this other line. But I already know that the gradient of this line is also going to be 1. All right. Okay, I'm going to give you guys a chance to try this question coming up, but I'm going to show you guys how to do the first question so that we don't get lost. Right, let's look at A. Now, we're told here, we're going to write down the equation of each of the following lines, and we've been given that they are parallel to another line. Now, remember the equation of a line is actually y is equal to mx plus c. And the thing that we have by knowing that they're parallel is just m. M is the only thing we have. But they want us to find the whole equation. Now, what they've also given us over here is if they've given us an x value and a y value. And I know that if I've got the gradient and I've got the x value and the y value, I can use those two things to find c. Okay, so if this is line 1, and I want to find the equation of line 2, I already know the gradient of line 2. Because they tell me that line 1 is parallel to line 2, what is the gradient of line 2? It is the same, correct, Abu. So the gradient of line 2 in this particular question is going to be 2. I've already got the gradient. Because the gradient of this line is 2, and those two lines are parallel, the second line will also have a gradient of 2. So I already know that line 2 has an equation of y is equal to 2x plus c. But now I want to find c. If I want to find c, I'm going to take the point that they've given me, and I'm going to sub it in here. Okay, I'm going to sub in the points for x and y. So I'm going to replace x or y with 8 and x with 1. So I'll get 8 is equal to 2 times 1 plus c. That tells me 8 is equal to 2 plus c. Move the 2 over to the other side and becomes negative 2. So therefore, c is equal to 8 minus 2, which is 6. That means the gradient or the equation of this line will read y is equal to 2x plus 6. All right. I know. And they're very dead because it's been a while, but they're also very famous. Okay, I'm going to give you guys a chance to do B and C. We're not going to do D for the sake of time because we still need to speak about perpendicular lines. Okay, so try B and C. Pop your favorite emoji in the chat when you are ready. Okay. I'm sorry, Gift. We're so sorry that it's Mr. Analytical's fault that you're struggling, that you're suffering. Sorry about that. Interesting, Narisha. I have my own theories about homework, but yeah. All right, let's have a chat about these questions real quick. Okay, let's look at B. So we are told that we are looking for the equation of the line that is parallel to y is equal to 3x plus 2 and passing through the point 1, 1. So I can already say that this is my x and my y value. And I know that because the two lines are parallel, that tells me that line 2 already has a gradient of 3. Right, so I've already got y is equal to 3x plus c. Okay, and then I'm going to replace my x and my y with the values that I've got. So I'm going to go 1 is equal to 3 times 1 plus c. That means 1 is equal to 3 plus c. We're going to move the 3 over to the other side, and it's going to become negative 3. Okay, so that becomes minus 2. So c is then equal to negative 2. 3 minus 1 is negative 2. Therefore, the new equation for the line would read y is equal to 3x minus 2. All right, that's B. All right, let's have a look at C quickly. For C, again, I'm told that the line is parallel to y is equal to 5x minus 4. So I already know my gradient is 5. Okay, and I've got my x value and my y value here. That is x and that is y. So I'm going to say y is equal to 5x plus c. And then I'm going to take 9 is equal to 5 times 2 plus c. That gives me that 9 is equal to 5 times 2 will give me 10 plus c. Move 10 over and it becomes negative 10. Therefore, c will equal 9 minus 10, which is minus 1. Therefore, y should be equal to 5x minus 1. All right. And oh, that is not the correct one. And that's how easy it is to get the answer that we're looking for this. All right. So can we chat about perpendicular lines? Because this is quite easy. We're looking at it now, right? We just know that if two lines are parallel, then their gradients are equal. Let's talk about perpendicular lines. What do we know about perpendicular lines exactly? Definition of two perpendicular lines: when they meet or where they cross, what should we have? They are, you're correct, but they should give us they must meet at 90 degrees. Correct. They must give us a 90-degree angle. Sure, no problem, Andy. So give me 1 second. Okay, there we go. Okay, this is A, and this is B, and that last question that we did there is C. All right. Okay, cool. So if I decided to take these two things, put them on a Cartesian plane, I'm going to draw quite a simple graph, actually. Right, let me draw the graph of a straight line through the origin. I'm going to draw it through the origin. All right, there we go. And then I'm going to draw another line that goes that way through the origin, and they're going to give us a 90-degree angle, right? Now, because they both go through the origin, what is the coordinates of the origin, guys? What is the coordinates here? Right here in the middle. That's it. Correct, Narisha. 0 and 0. Good. Okay, I can tell you're doing your homework. All right. So if I tell you guys that the point on this side is 1 and 1, and the coordinate that I have on this side is -1 and 1. Can we calculate we're going to call this line 1, and we're going to call this line 2. Can we calculate the gradients of line 1 and line 2? What are we going to get? The gradient of line 1. Okay, we can make this x2 and y2, and we can make this x1 and y1. Okay, remember that both graphs, they both share the origin. So I'm going to make this x2 and y2 as well. Now, if we calculate for the gradient of line 1, I'm going to get 1 minus 0 over 1 minus 0. And that's going to give me 1 over 1, which is just 1. If I calculate the gradient of line 2, I'm going to get my y value, which is y2. I'm going to get 1 minus x or y1, which is 0, over x2, which is -1, minus x1, which is 0. So the gradient of line 2 is going to be -1. So the gradient of line 1 is 1. The gradient of line 2 is -1. Now, if I then decide that I'm going to draw a parallel line to that line. I'm going to draw a parallel line. I'm going to draw a parallel line going up that way. Okay. Now, again, I've only moved this up. I've only moved the line that I'm drawing up, right? So this coordinate up here would still have an x coordinate of 1. It would still have an x coordinate of 1, right? If I've moved this up 3 units, if I move this up 3 units, what's the value over here? Good, Abu. Lovely. This is going to be 1 and 4, right? Okay, I just need to make sure I'm calculating correctly here. Okay, what is the gradient of this line over here? What is the gradient of this line? Remember, this line is parallel to that one. This line that we're drawing, we'll call it line 3. Correct, Tristan, absolutely. Because I've drawn a line that is parallel to line 1, and the gradient of line 1 is 1, it doesn't matter what we have over here, the gradient of that line will also be 1. Okay. So if the gradient of that line and this line meet at that point, right? What did we say the gradient of this line is, of line 2? Gradient of line 2 was -1. The gradient is -1. So wherever these two lines meet, as long as they create a 90-degree angle over here, it doesn't matter what those values are, my two gradients will always give me -1 in any direction. But that tells me that when I multiply them together, they're going to give me -1. Right? So if I have a line, I'm going to keep that line. I'm going to move that one. That one I'm going to keep. I want to use that one. If I decide to draw a line over here, if I want a gradient of, okay, I've got a gradient of 1 over here, right? That point over there where they meet is still going to give us a gradient of -1 if they are parallel. So the two of them together must give us a gradient of -1. Okay, so if the gradient over here switches from 1 to 2, what is the gradient of this new line going to be? We're going to name this line 4. Let's look for the gradient of line 3 and line 4. If the gradient of line 3 is 2, what is the gradient of line 4 going to be? Remember, together they must give me -1. It's not going to be -2, Tristan, because if I take 2 and I multiply it with -2, it's not going to give me -1. It's going to give me -4. Okay, so that can't be it. I want the two of them together to give me -1. So I know that M3 multiplied by M4 is equal to -1. No, don't say that, Oni. You're starting. No. Okay, it's not going to be positive. Let's think about this, guys. Let's make this x. Okay, I'm going to make the gradient of 4x. Right, I'm going to replace the gradient of 3 with 2. So I've now got 2 multiplied by x is equal to -1. Let's solve for x. 2 times x will give me 2x is equal to -1. What would x be equal to? X is equal to divide by 2, divide by 2. X is equal to negative 1 over 2. Oh, I see. Vukosi, don't start. Guys, please. All right, so the gradient between the gradient of that other line, or of line 4, needs to be -1 over 2 in order for the two gradients to meet at exactly -1. All right, so when we are looking at perpendicular lines, we said for parallel lines, we've got to have two gradients that are equal. For perpendicular lines, we need the two lines to equal m1 times m2 must equal -1. But we don't have to really belabor it. Here's what ma'am means by that. If my gradient 1 is 2, right? What I'm going to do is I'm going to change this gradient into a fraction. I'm going to do this. I'm going to make 2 into 2 over 1. If I want this to be -1, first thing I'm going to do is I'm going to give the second gradient a negative so that my answer comes out negative. And all I'm going to do is I'm going to take this and I'm going to flip it around, 1 over 2. Because the two of them together will give me -1. All right, so if I say to you guys that I have a line of gradient -3 over 4, I would have to multiply that with, because this one is negative, this one must be positive, and then I'm just going to write the reciprocal of that, 4 over 3. Because when I multiply them, this will cross cancel with that, this will cross cancel with that, and I will have -1 left. Okay, so if I say to you guys that I've got a gradient, one of them is -2 over 7. What is the gradient of the other line that is perpendicular to it? What am I going to get over here? Together, they must give me -1. So this one is negative, so I'm going to make this one positive. That's it, Tristan. And then I'm going to flip it over. I'm going to look at the multiplicative inverse. Positive 7 over 2. All right, are we seeing it, guys? So if I say to you guys, I've got one graph that is equal to 2 over 5. What is the perpendicular line going to be? That's going to give me -1. The perpendicular line should be negative. Good. Because this one is positive, this one would have to be negative, and then we would take 5 over 2. All right, so we just take the reciprocal of it, because when they multiply each other, they need to give us -1. They need to meet at the point where their two gradients are equal to -1. All right.